to True Projects. In this video, we are going to explain about the project that has upgraded machine learning techniques to forecast obesity hazards. So before getting into the execution, first let us understand what is this project about. Obesity. It is becoming one of the biggest health problems around the world today. It doesn't just affect one group of people, it can happen to anyone, regardless of age or background. The reason it happens isn't just because of eating too much, it is actually a mix of many factors like our genes, the kind of food we eat, how active we are, our surroundings, and even our financial situation. So it is not only about how a person looks on outside. Obesity can lead to serious health problems like diabetes, heart issues, that is the heart disease, high blood pressure, and even cancer. What's worrying is that the number of people who are overweight or obese is increasing very quickly, not just in rich countries, but also in developing ones. That's why it is so important to identify obesity early and take preventive steps, things like improving diet, exercising regularly, and spreading awareness to protect people's health before it gets worse. So, the main issue we are facing in the obesity is becoming more and more common, and it is not easy to figure out who is actually at risk before it happens. Usually people use body mass index or BMI to check if someone is overweight or obese, but the body mass index only looks at height and weight. It doesn't tell us the full story. It doesn't take into the account the other important things like person's lifestyle, eating habits, level of physical activity, or even their family and genetic background. So, to really understand and prevent obesity, we need to look at all these factors together. How someone lives, eats, and moves because they all play a part. If we identify people who are at risk early on, we can help them to make healthier choices and avoid serious health problems later. This isn't just about preventing diseases, it is also about improving quality of life, spreading awareness about the importance of staying active and maintaining a balanced lifestyle. So, the system we are talking about is meant to predict if a person might be at risk of obesity and to do this as early as possible. And to make these predictions, it looks at bunch of different health and lifestyle factors, things like your age, gender, height, weight, family health history, and even your eating habits. So, first the data we collect, in this case from a data set called No Obese Data on Kaggle. It is cleaned up to make sure it is consistent and it is in a usable format. Then we use some advanced machine learning algorithms that are XGBoost, CADBoost, and LightGBM to analyze this data. These models learn patterns from the data so that they can categorize people into different groups, whether they have normal weight or they are slightly underweight or overweight or obese. Basically, it is like giving the system a lot of information about the people, teaching it to spot who might be at risk. So action can be taken early once the models are trained. So here, once the models are trained, we need to check how well they actually work. We do this by looking at things like accuracy, precision, recall, and FN. So this analysis also shows the certain factors like a presence of weight, family history, and eating habits play a big role in determining obesity risk. Overall, this system is really useful because it provides a clear database way to identify people who might be at risk early on. And to further improve the performance of this project, here we are incorporating voting classifier. So as the next step further, we are using an ensemble model called voting classifier. So instead of just relying on a single model, it combines multiple results from several models and makes a decision based on majority. This way, the system becomes more reliable and stable because it reduces the chance of errors that might happen if we use only a single model. And on top of that, we are also using techniques called SHAP from explainable AI. This helps us to understand why the model made a particular prediction by showing which factors like weight, family history, or diet influence the decision the most. Essentially, it takes the system not just smart but also transparent so doctors and users can see the reason behind the predictions. Finally, we have developed a simple web interface by using Flask so to make this system easy for anyone to use. The app has a simple and user-friendly interface and even it includes secure login. to that user's information is protected. So users can enter their personal details like age, weight, height, and lifestyle habits directly into the app. Once the information is submitted, the system uses trained models, that is, trained machine learning models, to predict the user's obesity risk level. The results are then shown in a clear and easy to understand format so users can quickly see where they stand and take steps towards healthier choices if needed. Moving on to the implementation, to implement this project, we have followed these steps which are mentioned in the flow of work. So, coming to the first step, we will be importing all the necessary Python libraries required for data processing, visualization, machine learning, and web application development. Coming to data ingestion. At this stage, the obesity prediction dataset is collected from Kaggle and the dataset is loaded into Pandas data frame, which allows us to manipulate and analyze the data efficiently. Then comes data pre-processing. Here we handle missing values in the dataset either by removing them or filling them with appropriate values. We convert categorical variables into numerical form using label encoding so that machine learning models can process them. If the dataset is imbalanced, some categories have more data than others. For that, we apply sampling technique to ensure that all classes are fairly represented during the model training. Then comes data visualization. So here we use graphs, charts, and plots to understand the data better. This helps to identify patterns, relationships, and the trends between different features, making it easier to interpret the data. Then comes feature extraction. So here we select the most important features that influence obesity prediction. So we will be dividing the data set into training and testing sets so the models can learn from one set of portion, that is training data, and they will be evaluated on the other set. Coming to model training. So after data splitting, we will be training the data using the models, multiple models to predict the obesity. And we will be evaluating all of them using accuracy, precision, recall, FN score, and confusion matrix. And we will be applying explainable AI techniques to understand which feature contribute the most to the model's prediction, making the system more transparent. And we will be saving the best performing model for the future use. Coming to the front end part, so we have designed a simple and user friendly interface where users can input their details like age, gender, height, etc. And we will be loading the saved model, pre-processing the input data and generate predictions for the user and display the results on the web page in a clear and easy to understand format, allowing users to see their obesity and risk level instantly. So this is how we have implemented, and these are the algorithms used in this project. And to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap code. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So these are the source code files of this project, and let's understand what are these. So this is the model folder in which we have algorithm information, and this will be loaded into the project code during runtime of the application. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap 4, which are important for the project's visual appeal. And here we have templates folder. So this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases in which we have test cases that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have Jupyter Notebook file, which contains a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have data set that we have used in this project. Let's open it. So this is the data set used in this project, and here we have multiple parameters. So based on these parameters only, we will be training the model to predict the obesity. So now close this. And this is the signup.db file. This file is the database file which is used to store the user information. And this is all about the code folder. Now let's execute it. So to execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path, and click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the Flask framework, after running the app file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link and I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get signed up first. So click on sign up and give your details to create an account. I have already created account, so I'll directly sign in. Click on sign in. Provide your username and the password. Click on sign in. We have signed in successfully and redirected to this obesity prediction page. So here click on predict. And here you can see multiple parameters, right? So these are the parameters which are need to be given as input. So here we have gender of the person, we have age, height of a person, weight, family history with the overweight, high calorie food, whether he takes high calorie food or not, how frequently he eats vegetables, number of main meals he takes per a day. And here we have eating between meals, smoke, daily water intake, how much of water he takes intake. And here we have caloric monitoring. Here we have physical activity. And here we have tech usage per day. And here we have alcohol consumption. So how frequently he consumes alcohol. And here we have transportation, which mode of transportation he uses. So this is all about the parameters. Now let's enter them. So open test cases, open sample file. So let's try. So let's apply filter to this no obese tag, filter it. So let's apply filter to insufficient weight. So click on it and click on OK. So let's check with this case where gender is female, age is 23, height is 1.60, and weight is 45. Family history is overweight. High calorie food is no. Vegetables frequency is 3. Number of meals it is 3. Eating between meals it is sometimes. No smoking habit. Water he eats, she drinks 3 liter per day. And then calorie monitoring is yes. Physical activity is 2. Tech usage per day is 0. Alcohol consumption is no. Transportation uses public transport. Now click on predict. So here we got the prediction. Before getting predicted, what the data will happen is the data will be pre-processed at the backend. It will be fed to the train model, and then the train model will be giving us a prediction. And here application is predicting to meet as insufficient weight, which is underweight. And here we have confidence of 92.1% based on the input data. And here are the recommendations for the person. Now let's check with the other case. Click on back and let's apply filter to normal weight. So now click on OK. And now gender is female, age is 21, height is 1.62, weight is 64, family history is yes, overweight it is, calorie food is no, that is high caloric food is no, and vegetables is 2, main meals is 3, and eating between meals, that is eating between meals is sometimes, no smoking, 2, water intake is 2, and here we have calorie monitoring, it is no, FAF it is 0, 1, public transport, sorry it is automobile, and this alcohol consumption is no. Now click on predict. And here we can see a normal weight has been predicted with the 66% confidence. And the individual has normal weight based on the provided data. And these are the recommendations for the person who is normal. Now let's check with the other case where let's apply filter to obesity type 1. Click on OK. Let's fill in all these values. So let's check with this case where gender is male, age is 41, height is 1.8, weight is 99, family history is no obese, high calorie food intake is yes, 2, 3, sometimes no, sorry, it is 2, smoking is no, and water intake is 2, physical activity is 2, and this is 1, frequently, and here we have transportation is automobile. Click on predict. So here we got the prediction. It is obesity type 1, and here we have confidence of 79.2%, and this is the recommendations for the obesity type 1. Now let's check with the other case. So let's apply filter to obesity type 1. Click on OK. And let's check with this case where gender is female, age is 24, height is 1.6, weight is 100.5, family history of overweight is yes, calorie food intake is yes, 3, 1, and sometimes no. Smoking habit is no smoking. Daily water intake is 1 liter and SSC is no. 0, FAF is 0. Tech use per day is 2 and alcohol consumption is sometimes. Transportation is public transport. Click on predict. So here you can see it is predicting obesity type 2. Application is accurately predicting, and here we have recommendations also. Now let's check with the other case, that is obesity type 3. Click on OK. And let's check with this case where gender is male, age is 18 years, height is 1.87, and weight is 173. Family history of overweight is yes, and high calorie food intake is yes. Vegetable frequency is 3, number of meals are 3. Eating between meals is frequently. Smoking is no. And CH2O, that is consumption of water, is 2 liters. Calorie monitoring is no. 2 is physical activity. The usage of tech, it is 1. And alcohol consumption, it is sometimes. And mode of transportation is public. Now click on predict. And here you can see it is being predicted as obesity type 3 with a confidence of 87.0%. And here we have the recommendations to consult a healthcare professional urgently. Let's check with the other case. So let's apply filter to overweight level. Click on OK. So let's check with this case. Gender is male. Age is 29 years. Height is 1.77. Weight is 83. Family history is no. Calorie food intake is yes. Frequency is 1. 4. Frequently, that is eating between meals is frequently. Smoking is no. CH2O is 3. And this is caloric monitoring. It is no. Physical activity frequency is 0. Tech usage per day is 1. No. And motorbike. He uses motorbike to travel. Click on predict. So here you can see overweight level 1. So he is at overweight level 1 and with the confidence of 83.8%. And here are the recommendations for the person who is overweight at level 1. Now let's check with the last case. So let's apply filter to overweight level 2. Click on OK. Now let's check with this case where gender is female, age is 30 years, height is 1.71, 82 kgs, family history is yes, calorie food intake is yes, and 3, 4, frequently, yes, 1, and no. Here we have no. FAF is 0, Q is 0, and alcohol consumption is no, and transport used is automobile. Now let's click on predict. So here you can see overweight level 2 with a confidence of 73.5%, and here we have the recommendations for the person who is at overweight level 2. So this is how you need to do the prediction. Now click on graphs. So here we have graphs. So this is a sample outcome graph where on x-axis we have all the targets that we are predicting and on y-axis we have count of each class. Close it. And this is the confusion matrix. And here we have, this is the confusion matrix and this is the multi-class ROC voting classifier. So here on x-axis we have predicted level and on y-axis we have true classes, and here on x-axis we have false positive rate and on y-axis we have true positive rate. And actually this is correlation matrix which shows the correlation between independent variables. And here we have accuracy score. So here on x-axis we have all the algorithms that we have trained and on y-axis we have accuracy. And here we have precision score. This is the precision score comparison graph. This is the recall score. This is FN score and this is ROC curve graph. Now click on logout. So in this way, just by giving all the required parameters to the application will be accurately predicting the obesity level, which helps the patients as well as doctors to take a preventive precautions. This is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.